This is talking about delivering a data warehouse in the cloud. Oops, this is not hooked in. One moment to do this. Make my life easier. Okay. So if you can, please silence your cell phones. Again, I think everybody have seen these slides, but there's a lot that PASS has to offer and explore. So who am I? I'm Jeff Renz. I'm a senior BI architect with RevGen Partners. I have an extensive background in manufacturing, worked on different telecom systems, been in the data warehousing space for a really long time. I'm also working on improving my data science skills through some advanced education. I'm actually halfway through the Harvard Business Analytics program, so that's been really fun with some R and Python and thinking through when we're working with the business, how to best deliver results. So different perspective, but definitely a lot of fun and some challenge involved there. I know it's being deprecated, but I actually did complete the Microsoft Big Data program. So there was a lot of people, if you had done edX classes, a series of stuff on big data. So I completed all those pretty cool classes, but it was good to get the background and understand a lot of concepts, including Azure SQL Data Warehouse was part of that. So I'm going to share some things there. So what we'll talk about is Azure Synapse Analytics, which I think everybody is like, interesting. We had a big change. That's cool. We'll talk about some basics on designing and querying our tables, loading data, and then some data warehouse management concepts that we would care about. So let's talk about Azure Synapse Analytics. So, like, what the heck? So I was preparing for the presentation. It was a little bit of a shock when I was going through my slides that there was this big change that occurred. All the documentation had changed. I'm like, are they dumping SQL Data Warehouse? Should I be concerned about this? So there's a lot of reference material that I provided to everybody, a bunch of links on the overview of what it is. And it did take me a little bit of time to digest after the keynote and a couple explanations by Microsoft what you actually have and what you can do. So what really happened to Azure SQL Data Warehouse? So you could say it actually evolved, that it's still there. You could go to the portal, you could still provision it. It didn't go away. It does have a different name. It is a Synapse, just call it with that. But there's a lot of stuff now that's in preview. So you might have seen in the keynote the portal and some stuff with Power BI and some stuff with Flow. You can't get to that. You have to request permission, and then you can see those things. So this isn't going to focus on all the new stuff. The idea is we'll focus on the fundamentals of what is Azure SQL Data Warehouse, how it's different than a Azure SQL database instance that you're probably used to working with or have heard about. So what are we trying to do? What's appropriate usage that we would have for our data warehouse? So we do want to centralize and consolidate multiple data sources. I don't know, did anybody attend the innovative data modeling session that I had with Leslie where we're talking about Data Vault? And so a few people. It's one architecture that actually fits really well with the Enterprise SQL Data Warehouse. The other one is the normal dimensional modeling, Kimball style, fact and dimensions, where you would load data in. You do want to be able to do historical reporting. Your data warehouse should have data archival. You're going to have batch and in some cases transactional. So back when I spoke about manufacturing data, we actually had line data coming in batch from our solar panels that we were loading into a data warehouse. And at the time it was on premise, not a big deal. We just didn't have the really cool Azure technologies that we have now. But there is a consideration, though. If you're going to use Azure SQL Data Warehouse Synapse, there's a minimum amount of data you really want to be working with, or it's not worth the extra cost and a few different implementation details over Azure SQL database or working with an on-premise database. So the basic rule of thumb is the data warehouse size would be over 1 terabyte, and then if you have large tables, over 1 billion records. So nowadays that might be more common. Anybody working with data in the billions right now with rows? So handful, yeah. So it could be a good fit for you. We've always heard scaling up and scaling down and pausing the data warehouse is a nice Azure feature that we can't necessarily do with on-premise databases. So I just wanted to repeat what hasn't changed. So data warehouse is still platform as a service. It's elastic. You could scale it up, scale down, has the enterprise capabilities. It does support small and large data sets. When you do work with small data sets, there's some table design considerations to make it perform better, and we'll talk about that. It's a node architecture. So has anybody worked with a different platform that's a node architecture like Teradata? And if you haven't, that's okay. Big telecom, we actually had a Teradata instance, multi-node, $1 million platform that you would have on-premise with the nodes to give you the multiple processing capabilities. So this is a cloud instance that does the same thing as an on-premise physical box that has the nodes on it. When you're talking about cost and compute power, you're going to have these data warehouse units. So there's a Gen 1 and the Gen 2. So we moved on to the Gen 2, and I don't even think you could provision a Gen 1 data warehouse unit. So what is this data warehouse unit? And this is where things can get very interesting and can be a little bit abstract. But it's really defined as a combination of CPU, memory, and I/O. So things are bundled together. You're going to get compute. And so that there's calculators on how much compute you get. So I have some slides coming up that will explain when you're scaling up compute, what's really happening behind the scenes, and how it's working within MPP architecture. So again, the database warehousing unit's a little bit abstract. You could change your service level to alter what you get. So if you look at, there's an actual pricing calculator. So you could go to the Azure website to play around with the pricing that you have. And the pricing is different per the region that you're in. So in this example, I'm working with West US 2. You could see that what's selected is the optimized compute for Gen 2. There is some discounts. So if you lock yourself in for a year of reserved, you could get a 37% discount, 3-year 65. So we'll play around with that a little bit. The minimum setting is the 100 database units, which is roughly, if you're on a monthly basis, about $876. And then storage is separate than compute. So again, based upon how much data you're loading in, you're going to get charged quite a bit for that. But if you're using like the column store indexes and compressing data, you definitely want to do that. Don't create tables and purposely not use column store compression. So you could save some money there. Might be a little hard to read, but these are all the different pricing settings that you have. So you could be as cheap as $1.20 an hour and go all the way up, I want to say like $180 an hour. So we'll get into the calculator to see what that really means if we would want to scale that up. But I definitely run out of my Azure credits in my demo if I did that. So I will not be doing the top tier performance. So again, at each performance tier, you're going to use a slightly different amount of compute measured in the data warehouse units. You can scale up and scale down. Part of some of the fun with the Azure SQL is things are based on an hourly charge. So if you scale up some things and you're using the compute, it's going to use that until you pause it. And so keep in mind, pausing can be a bit tricky. If you have loads and other activities, it could actually take a while for your database to go offline. So be aware of that. It's not instantaneous that the data warehouse is pausing. Gen 2 has better performance. It has a local disk-based cache to improve the performance. And then you get a period of caching warm-up for optimal performance. So that's, keep that in mind when you're spinning things up. It takes a little bit of a while, but then it'll be fine. And then the idea is as you increase performance, it's linear. So instead of having diminishing returns, if you're trying to scale up a normal SQL data warehouse, it isn't linear. This is linear. So you're getting the value that way. So a really interesting question might be how many database or data warehouse units do you really need? And if you're thinking about what everybody would do, why not start with the smallest amount of your data warehouse units that you're going to be working with and see what you get? And what sounds reasonable to you? If you have a valid solution, and when we were working on some examples, if I were to load maybe 40 million records into a table, what kind of performance do I get today? What kind of query performance do I get with the lowest setting? And is it better than what I have? If I have a Azure VM that's set up, what does that really look like? Can I get away with $1 an hour, or do I need to be $10 an hour? So there's some tuning. And again, turn things off. Don't do it in your production instance that you're really working on. You could play around with spinning up another one on the side. So that works really well for figuring that out. And then you can figure out peak activity. So if you're monitoring and you know you have heavy usage, so at night when you're doing your ETL loads, definitely spin it up more so you can get the compute and loading things through. Then it's done. Scale it down. No need to waste the money when nobody's using it. End of month is always big. Everybody's trying to process the data for end of month, so you might just plan for that. You're just going to keep it at a higher level of performance. So let's go ahead and look at what it looks like in the Azure portal to spin up an instance SQL DW. So what you'll do in the Azure portal is click on Create a Resource. So you're going to see this Azure Synapse, formerly SQL DW. So a logo change everywhere, formerly SQL DW. You're not going to see any other features. That's all you're going to see right now. Everything else is in preview. So you can click your Create. So then you're going to choose what subscription you're working with. So I have a few. So I'm going to go ahead and use my Visual Studio Enterprise. You could create a resource group or use an existing one. So I have my past demo resource group. So I can say pass demo. So you'll notice everything's okay with the names. I'm not repeating things. And then you have an existing server. So your server can hold regular Azure SQL databases and SQL Data Warehouse if you have. You don't have to create a new instance for it. So I'd say I'm just going to put it on an existing one. So this is where, be careful. This is on Gen 2. And notice it's at 1,000. So that's not the cheapest setting. And if you just click Go, how much do you think we're costing ourselves if we go with the default? Well, let's see. So if we look at this, we're going to be $12 an hour. I could do it for a few hours, but I don't think I want to do that for my demo. So you could just use the slider and scale it down to get the $1.20 an hour. So I could afford that. I'll basically, I could still buy my coffee and be good by using this for the demo. So really, really easy. So I'll hit apply. And so it went ahead and it changed my performance level down here. Good to go. So you click the review and create. So it's going to spin up a new instance. It's going to call it past demo warehouse. It's at the Gen 2 level, so I'm just going to hit create. And so now, way up at the top, you get this deployment in progress as it spins up. So, yeah, go ahead.
Instance or database?
So it's a on the SQL server, it's adding a data warehouse database to it. So what that would look like, I have. I called it the LWJR server. And so these were existing databases in here. And then this is an example of an old Azure SQL DW instance. So those are existing. So I'll see another data warehouse instance on that server when it spins up. And you notice icon's different. You get the cool 4 little cylinders in it, so you know you're working with Synapse and not an Azure SQL database when it's created. If we go to the pricing calculator, so again, let's just go to pay as we go. So if we were figuring out how much we're spending in a month, we could play around with this. So again, this would say I have $1.20 an hour, so I'm going to spend $876 just on compute for the month. And then this is the storage. So you could play around with that as well. So if I'm going to just work with a terabyte of data, that's $122 for a little under $1,000 a month. So when I was, just one moment. So when I worked in the cloud with data warehouses, you have the option I could spin up a VM. And then if you have SQL licensing, you could get a discount on that. So I'm roughly spending about $1,400 on a production SQL instance where I'm doing some warehousing. It's not a big warehouse for the current client. We have a table of 20 million records, so it's not quite fitting into the Azure SQL Data Warehouse space, but we're on the cusp. So we would want to actually think, if I got away with $1 per hour and the probably 3 terabytes of storage for this moderate-sized database, we're almost even. So it might be worth doing the Azure SQL Data Warehouse versus the VM. And if we're saying pros and cons, well, this is managed, we have the backups, there's things I don't need to do. It's a bit better. There's a few drawbacks, like if you do have a VM, there's some tools like MDS that you could install, would be a little harder that you couldn't do with a SQL Data Warehouse. So there's still a few trade-offs that you might keep in mind if you're making those choices with a calculator. So my favorite thing is, how much do we think if we spin up max amount would we spend in a month? Any guesses? About $100,000 a month? Let's see. Oh, $250,000 a month. Ooh, that's a bit pricey. So that might not be a valid option for some businesses to spend that. So I definitely would pause if I was at the really high level. That's a bit nuts. But that's why we play around with it. However, if you do 3 years reserved, now you're under $100,000 a month. So again, you might say, what is my commitment level that I would have to Synapse to say, I'm just going to be all in, I'm going to invest for a year. And definitely overall with Azure pricing, if you feel like you're going to make a commitment, at least go with a year, because you'll get a reasonable discount on VMs and other solutions that you're spinning up.
Have you seen the multi-year commitments as they've changed products around? Have they honored that towards migrating you to a new product, or continuing to support the legacy?
So there's some things too, based on your company size, you could do some negotiations with Microsoft to get some discounts on some things. So if you're a really small company, I don't know if they'd be as willing to change some pricing around. But they are open to negotiation if you're a bit bigger. Yeah.
Is it possible to use like reserve pricing as a baseline, then still scale up?
Yeah. Yep. So what would happen is if you did the reserved, and so you started off at the 100, you're like, I'm not going to overinvest, I'm going to play with some stuff. So your budget that you put in is like, I want 12 grand a year to do some minimal stuff with my data warehouse, and you realize, nah, that's just not going to cut it, so you go to 200. So you still get that applied 37% discount that you're locked in, so you could go up and down. Yeah. Yeah, and it is pay as you go and pay as you scale on things. It's just, it's making that commitment. Like, I think if you're really going to go with it and you're not playing around, just say, we need to try it out for a year. And then after that year, you could actually see, is a price that I expected and I'm paying too much. I know just some people I've been chatting with, there was some disappointment. Like, I felt my Azure bills were way too high on some things that I had spun up with my SQL Server instances. So my thought again is, did you think about like elastic pools? Are you using managed instances of SQL when maybe you should have spun up a VM and created more databases in the VM for your solutions versus all these databases. Can you merge some things together into one that you might not have had? So there are options to lower your Azure bill, but you have to be very strategic in your thinking on what's going where with the Azure resources that you have. So little tips and tricks. Any more general questions about the pricing and how you scale up and scale down? It feels really easy. You know, I like the slider. That's a really great thing. Okay. So actually, one last thing. So we tried to spin up our warehouse. It says deployment's complete. Go to the resource. So it's available. So we can see it's running. But not really doing anything. If I come back to Management Studio, so this was pre-clicking the go. Let's see if I can refresh here. And there we go. So now I have another data warehouse instance on the server. And again, some more pricing tips and tricks is try to keep your stuff in the same region. So if you're moving data around from the different regions and the resources in the different regions, there's different costs per region as well, which I actually meant to highlight. So if I went back to the pricing calculator, so this was US West 2, where we were getting, let me go pay as we go. So the $1.20 an hour. If I go to the East region, say East, West, there we go. So if I was in West US versus West US 2, you notice it's $1.50 an hour versus $1.20 an hour. So it's a little bit more, so you want to do your research on what regions you want to put your stuff in. Slight changes.
Why though?
What was that?
Why the price changes?
Per the regions, why is it? So I'm not a Microsoft person, but my understanding is they have the different data centers, and they probably have different costs per the data centers on how things are utilized and things that are there that would drive the price. But yeah, I don't specifically know why they can't charge even fee per the different locations. You would think that would make sense, but they are slightly different. Yeah. Yeah, price like move here. Yeah, makes sense. Otherwise, people would just be clicking the same zone, and yeah, that definitely makes sense. Okay. All right, so we figured out some cost, but we hear massive parallel processing. So what is massive parallel processing? How is this different than a normal SQL Azure database that we have? So what you're going to actually get is a bunch of complex queries are going to be broken down into smaller pieces and executed in parallel, and that's called node-based architecture. So again, going back to like a Teradata appliance example, you would spend millions of dollars on an on-premise node-based Teradata solution to do MPP. Working with Teradata, some interesting things, if data isn't spread out and it's too much on one node, you could run into what's called a spool space issue, where it can't process everything on the one node and your query fails. So there are some tricks in Teradata that the Teradata administrators would do to have some statistics and move the data around so that it's more equally distributed across all these nodes that you have. Playing with Azure SQL DW, I haven't run into similar things that I've seen on Teradata. It feels like cloud-based and how the architecture's set up. We've run into less pain points compared to a Teradata appliance. But the idea is you're going to accommodate these larger workloads by adding what we call more nodes for the compute nodes. So a key concept is you're going to have this control node that's in here in the top. So what it was, a control node acts as the brain for everything that's inside the data warehouse. And then the compute nodes have their own CPU memory and subsystems. And so when you're scaling up and you're paying for more performance, you're adding more compute nodes to do things to get more throughput. That's what you're really paying for. So it's scaling up per the tier gives you those extra compute nodes. And then storage is actually separate from the compute. So you're really not scaling up the compute. And you can see in the bottom of the slide, you have your Azure storage behind the scenes that you're paying for. Something to be aware of is there's this data movement service that is part of this, and it's considered overhead. And you're not able to control this, but when queries are run and you have data on different nodes, sometimes they have to be moved around and put together to combine the data to return answers back in queries. So the data movement service is a thing that happens behind the scenes. So there's some strategic things you could do, especially with small data sets, that can help you get better performance and minimize some of the data movement. So that's some advanced concepts we won't get into, but be aware of when you're working with the data warehouse, you can improve and minimize the movement for better performance. Yeah?
So on the last slide, you mentioned that you can scale up and down the compute nodes.
Yes.
Now, if that was the case, then why do we select the fixed pricing up front on certain DTUs?
Yeah.
If I could scale up and down here, and how does that play a role?
Yeah, so let me back up to make sure it's really clear. When you do that $1 an hour, you get one compute node. So you have distributions, and I have a slide that will talk about the distributions, but you have one brain, which is a control node, and one compute node. And so you're not getting as much throughput because you're not scaling out across the compute nodes. So that's the deal, why you're paying for more compute nodes to do more things in parallel.
So it's the multiplication of what I selected up front, basically. That's what it will be.
Yeah, it will be. Yep. So if you, in this picture, if you had 4 compute nodes, you'd probably have selected the DUTs with the 4, and then you get the 4 compute nodes. Okay, so again, keep in mind when you design your tables and your queries run, data is going to move around, and so you want to minimize that. So the distributions, this is where I have a slide coming up that will tie to your compute node versus the distributions. But I think of it as if I had a SQL database and I created 60 of these databases, that's like my whole infrastructure that I have with the warehouse. I have all this parallel stuff I could do across the databases. So I think of it that way. The 60 smaller queries are going to run across all these instances that I have. And so with, next slide, one compute node that I paid for on the minimum level, I have that one compute node trying to move and figure out everything across all 60 instances that I have of those Azure databases behind the scenes. But if I move it up to the DW 600 level, I've added 6 compute nodes. So you have one compute node managing 10 databases behind the scenes for the parallelism, and so you get the better performance. So it's one of those a little bit abstract ideas on why I'm paying and how it really works behind the scenes. But that's the difference. In my mind, I think of it as several databases working in parallel together to give me results versus if I was in a single instance of SQL, I could just scale that one up, but I can't scale across with all these resources. Does it make sense to people? Okay. So something I've always run across and will have continual questions and debates is I hear data lake and I hear data warehouse, and I really get confused. Should I not have a data warehouse? Should I only go to a data lake? Should I do less with a data lake and more with a data warehouse? So I just wanted to address that so that my point of view on everything that you have in the Azure ecosystem and how it fits together. So you are going to have SQL databases. And so if I had a SQL database, to me I have an application, web app on top of it, mobile app, whatever. I'm going to be writing data to that SQL database. My SQL data warehouse, that's where I'm going to integrate all this data together from the systems in a structured data manner. However, I am going to be getting data from some different sources, like into Cosmos DB or HD Insight into the data lake, where maybe I have web logs, you have clicks that are coming from the applications, and you're collecting all this metadata information around what users are doing with your apps, stuff that could be mined from a data science standpoint to figure out customer preferences, what's really happening. So you need a place to store that, and that would go into your data lake. So a picture from an analytics standpoint would be, I'm going to have these people that are clicking on stuff in the shopping carts, looking on websites, to graph data, to images, to saving tweets, to IoT data. All that stuff I really see going in your data lake, which is really important. But now you're going to have some tools with the ingestion then. So you're going to manipulate that raw data, and then you're going to want to put it in a big data store. So you could work with Azure Databricks. And has anybody attended any Azure Databricks sessions so far? Yeah. I consider that as an important tool moving forward to complement what you're trying to do with your data warehouse architecture so that you can work with the raw data and put it in a structured format so that it goes in the warehouse. It's definitely part of it. And so the data warehouse piece then is I'm going to model it from a business standpoint and serve it back out. So you're not going to hold everything in your data warehouse. I would not keep every single tweet, every single blog entry. That's going to stay in your data lake, but you're going to mine that stuff with Hadoop and Spark and machine learning to bring it up a level where it fits at a grain that makes sense for analytics, and you store it inside your data warehouse. And then you've combined data that is predicting things and insights with actual business data from your systems so that you get a nice view out to users. And then from there you can decide, am I going to put like an analysis services tabular model offside the data warehouse so that maybe Power BI talks to it, so you could consider the scaling up and the scaling down of the data warehouse. If you put analytics on top of it, you could scale down your warehouse and pay for less, but you served your tabular model that you have. So those are some very valid options for it. So I really like this definition. Data warehouse is highly structured with your data. So it does require a lot of amount of discovery and planning and modeling. And so again, data modeling isn't dead. Working with the business users, understanding how the business works. You want to design your warehouse that really meets the need and calls things from a business perspective and joins that data together. The data lake, you need a place to save all this raw data in the native format to do stuff with it. So a lot of times it's semi-structured, could be completely unstructured, but it's important. You can't nowadays get away without having a data lake. It's very valuable data, and there's a lot you can do with it. So this debate again, data warehouse versus data lake, message is both. You really need both because they have different needs and different use cases. You're not going to dump one. You are going to have a traditional data warehouse, and I won't get on my data vault soapbox on how you model things and some future ways of agile development inside the data warehouse. That's a full hours of discussions and things, but there are new ways to model your data faster so that you don't get the perceived, I have a data warehouse, takes forever, I can't deal with it. Then in contrast, you get all the data all the time going into your data lake. There's some great tools like the Delta Lake with Databricks. You could time travel back in the data lake, compare versions of things. So the tools are coming along. You're seeing notebooks now. You're not having to do command line things in Scala and SSH into Spark. There's some really nice tools to help you out there. So the types of stored data, again, structured data in the warehouse, data lake, any type of data, any format, doesn't really matter. You're going to hear, prior to the data warehouse implementation, you're going to have schema on right. Figure out the schema first, and you're going to put the data in it, versus data lake, I'm putting data in, I'm figuring out what the schema is, and I'm putting it on top to get at it. From a price versus performance, so this is one of the faster, easier ways, again, how much resources you have, but a higher cost of storage, really, to put things in your data warehouse. So that grain's important. Again, keep all the lower stuff in your data lake because it costs you a lot less money, low cost storage. If you think about the highly curated data, and you've heard central version of the truth, that's pretty common with the data warehouse. That won't go away. But raw data in the data lake isn't curated. And so if, let's say, you were curating things and you didn't do stuff right, you could always go back to the data lake and rework with that data and put it back in your data warehouse so you didn't lose anything. So analytics patterns. You're going to have the continual batch reporting and BI visualizations. That's key working with your data warehouse. Versus data lake, you're really going to be working with machine learning, predictive analytics, discovery of data, knowing what's important to you. Maybe you're not collecting something, then you have another version of getting logs and things and seeing what's happening. Types of users that would be caring about things, so business analysts will want to hit your data warehouse. Not to say that your data scientists wouldn't, but data scientists are going to go to the lake. They're not going to wait around for your IT group to structure everything and put it in the warehouse, and business analysts as well. And in the data lake, you can curate some of that data. So does that make sense? Are people maybe a little less confused about data lake and how it complements the data warehouse? Okay, good. So what is different when you're working with Synapse versus a traditional SQL database? So there's a few things that are different. So when we're creating a table, we're going to notice a new setting that we're going to have, the distribution column. How are we going to distribute the data in the table across all of our nodes, distributions that we really have? And there's a couple options with that. So you'll see in this example, you're declaring I'm using a clustered column store index plus the distribution is hash, and it's pointed at the customer ID. So the one limitation is if you're using a hash method, you get to select the one column that has the data that's being hashed, and it's going to put the data across the different distributions according to how it's coming out and being hashed. So ideally, things hash evenly, and they're put in buckets, and you don't have a odd distribution of data where some distributions don't have data and some have too many. You want to have balanced. And we'll talk about this in a bit more. You also have the concept of these external tables, which is a very important concept. You're going to have external data that isn't in the data warehouse, that would be in like Azure Blob Storage, and then you can do the schema on read, and it appears as an external table to you. So you could put it in your data lake, HDFS, or in Blob Storage, and it's an external table. So the round robin distribution, so this is the simplest. If you just say create table and you don't define what kind of distribution you're going to have, it's going to default to the round robin. So it does deliver really fast performance for the staging table loads, and that's a best practice when working with Synapse is that you're going to have a staging table for your loads when you're running things. So it is going to 100% distribute that data evenly across all your nodes. It's going to go node 1, then node 2, then node 3, node 4. So you get 100% even distribution. And it's random where it starts, but once it is, it's just going to keep going across all your nodes. But you're going to see a drawback. So when you're joining across the tables, there's some reshuffling of data, so it's not optimized for some queries. So when you're thinking about benchmarks and things I'm doing quite a bit, this is where it might affect the design of your table when you're seeing what kind of performance you're getting with that data movement service, moving data across nodes on specific queries. The hash distribution, this is where it's going to divide the data across the node. And so when you're hashing that column, like the customer ID, or maybe you'd hash like a last name, it'll put things in buckets. And so some of the queries that you have, all your data would be contained in one node. So you're going to have less overall movement of trying to get your answers back if they're in the same compute node. So you can get very fast query performance on large aggregations and tables when you do that. So again, it's based on an algorithm. You don't really define the hash. The round robin is default. Once you get going with Azure SQL Data Warehouse, just play around with it with the base default round robin table and see what kind of query performance you get with it. And then you could shift to hash and play around and say, how am I really improving my results back with what I've hashed? That's just makes a lot of sense. So small amount of data. So you could actually create this thing called replicated tables. So let's say you have a date table and you're listing everything out. That's a small data set. So if you declare it as a replicated table, it's going to take that date table and put it on all the nodes. So then when you run a query, it's not going to move the data around to join it. It's already there, and you get faster performance. So that's, again, utilized for the small tables. The downside for the performance is you're storing that small data on every single node. So you have 60 times that amount of data going across the nodes. So again, you have to play around with how much is small that is worth the cost and the performance trade-off that you get creating a replicated table. You can create temporary tables. So what they'll do is they'll exist at the session level. So if you're in SSMS and you're creating your stored procedure and you want to load stuff into a temporary table, that works just fine. So in this case, once a session's over, it's dumped, so you don't have to worry about cleaning it up, and you don't have temporary tables hanging around. And one of the things for performance, the results will be written locally than remote storage. So if you had blob storage or you were accessing your data lake, you could bring some data into the temp table, and then you could compare your target table. I'm going to insert records or update records, so it is a common practice for doing that. You can partition as well your table. So if you think about data is being stored, if you use round robin, it's going across all the 60 nodes, and you have lots and lots of data, you can add additional partitions to spread the data out even more. And then based on partitions on normal data warehousing, you can jump to that one partition and work with a partition on that data. So it's again, optimized way of getting at sets of data. And you'll see 99% of the cases when you have partitioning, it's really partitioned on date. That's one of the most common ways of doing that. Slightly different than SQL is you will just say the partition, in this case, the order date key, range right for the values. So you've defined it there. So it's a little bit easier than if you were doing partitioning in the past in SQL Server. You just define that right there. So that's good. Simpler is good. So if we're thinking about over-partitioning, we're a little zealous. So again, we're writing the data to these 60 different databases. It's going to further divide your data. So if your goal is that each partition, you need 1 million rows to benefit from the performance of your clustered index, think about how much data you have. So in an example, if you create a large table into 100 partitions, then you need at least 6 billion rows to benefit from that. And why is that? You have the 60 distributions, 100 partitions, 1 million rows per partitioning. So you need some strategy here. Don't over-partition, because then you lose the benefit that you have. It just doesn't help you out. So those are common mistakes that people would make. The different types of indexes that you have. So you could have a heap. So this is recommended for staging temporary tables or small tables with lookups. Just make sure that it's not too big. You think you have a small table, it's going to do full table scan. Be careful there. You can also create these clustered indexes that you have on a table. So again, up to 1 million rows is what's suggested if you do a clustered index. Large tables, and just have to be a little bit careful with that. And then the clustered column store index, large tables, more than 1 million records, really is a good thing, and it's a default. If you don't declare it in the table, it will auto-create that for you. So what that looks like on table creation is you're going to create my table. So you'd say with clustered column store index. You don't say what columns are part of it. You just say column store index, and everything in the table is part of that column store index. If you were doing a clustered index, that would be similar to probably a traditional table with a primary key. You just say what column it is. So in this case, it was ID that you created a clustered index on. And then you could still do a normal index. So just create index if you're indexing zip code from my table on zip code. So you get that same indexing capabilities. So another thing is the statistics management, which is always important. So I don't want to go too DBA level on stuff, but you do want to keep track of your statistics. You have the auto-create statistics on. If statistics are missing, the query optimizer will create some statistics for you. So there's some example SQL in here how to do that. But if you do some statements like select or insert select, it'll trigger some automated creation of statistics for you. So that seemed to be new with the most recent release of Synapse, that you get some extra stuff that you didn't have before. that was new. Okay, so then after loading data in the warehouse, you're going to collect statistics, which is the most important things you could do. If you didn't manage statistics in like a Teradata appliance, some stuff will just flat out not run. You have to have statistics. So the nice thing is Synapse gives you these capabilities a little bit easier. And then it will use a cost-based optimizer when it runs on your queries to, most of the time, what I was reading, it will pick the lowest cost query for you to get your results back when you run it. So what I'd like to do is a quick demo of creating these tables, what it really looks like through script, and then we'll get into a benchmark. All right. So something that I did ahead of time was you could create users. So you create a login. So I did this loader RC20. If you wanted to do the same example, I have the link to the site. It's pretty cool. It should work for you to play around with this step by step. But you create a login, and then you create a user. So that normal stuff. Oops. Oh, sure. Okay. So in this case, this is our data warehouse, and then we're just granting control on the database. So basically, you're like a DB owner that's created for adding the user to that role. So if I run this, do this on my sample data warehouse, click the run, we're successful. Next one is to start loading things with PolyBase. I have run this already. You do it one time once you create your database, but you create this master key. You'd run that, master key is created behind the scenes. This next step, go here. So what is this step? So we want to create this external data source to our warehouse. So this is the NYC data set, and this is actually out in storage. You don't have to pass credentials in to connect to this public data set. So you could literally go home on your laptop, create this data source, and work with 2013 taxi data. It's a public data set that's available to you. So when we run this, it's created. What did that actually do? It created this data set right there. So it's mapped. We have access to it. So the next thing we're trying to do is we could create our uncompressed CSV. We're going to say the delimiter is pipe delimiter. So this is pretty boilerplate stuff with defining what our compressed file format is. So if I run this, oh, it already exists. I didn't clean it up. So if we look at the external file formats, you can keep adding different file formats for it, but I already loaded that. It's defined what our uncompressed CSV looks like. So then you could always do these create schemas. So if we look in here and we have schemas, I have a ETL schema and an external schema. And a good, when I'm creating the external tables when they're running, I like the EXT in front of them so that I know it's coming externally. You could say everything coming in that staging, maybe EXT or an ETL table. All that is possible. So when we talked about schema on read, this is what's happening. So it's going to files that are in our data lake, and it's going to put this format on it. So we're going to create an external table date. So we're going to have date IDs and keys. What's important to understand is it's coming from our source, the New York Transit Public. Okay, we're going to create a geography table. We're going to create this license. medallion, and the timetable, and then a trip. So I'll go ahead and run this. And be a few seconds here. Okay. So if we do a refresh, so even though the data isn't in the database, we now have these external tables set up that are pointed to our data lake. So we're seeing them as tables. So that's a really cool thing, and we define what those columns are going to look like. So it looks like a real SQL table pointed at the data lake. So I'm like, hey, this is cool. I could work with this. This makes a lot of sense to me. The next step then is we're going to load data via PolyBase. So if you read online, how's the fastest way to load my data warehouse? Everything is going to be PolyBase. You want to use PolyBase. There's different ways you could load it, but PolyBase is the fastest way. So what are we going to do? We're going to create our DBO tables, which are part of our data warehouse. We're going to say round robin because it's the easiest. We're going to use column store indexes. Not really highlighted, but something that you tend to do is add a lot of labels. So if you're a database administrator and you're trying to figure out what's happening in my data warehouse, labeling your tables and labeling stuff, you could see stuff in the DMVs to figure out what's happening. So it's extra goodness. Don't forget to do that. So we're going to create, for every external table that we map to in the data lake, a physical table inside the data warehouse, and this is going to load data into it. So let's see, where is this? A create table, yeah, with. So let me go ahead and run this. Point to the right database. Okay. So this is going to take a while. What we are doing is loading roughly 50, 60 million records. So my colleague Dan and I were playing around with this. We were really like, we hear the hype, we went to the keynote. Could we really load anything on the minimum $1 an hour credits? What would we really expect with this? When we did our bench run, basically, I think it was under 9 minutes, we loaded this 2013 taxi cab data, which was over 40 million records on the $1 per hour setting. So I'm like, you know, that felt really good to me. It feels like there's some minimum amount of oomph I could afford where I could see some performance with it. So we're not going to sit here for the 10 minutes to let this load. However, there's a few smaller tables that will start appearing. Okay, so these are already done. So it created the date tables. And so you're going to see it matches the schema that we defined for the schema on read. And then if I were to do like a select top 1,000, I'm getting my results back. So that was a really quick load with PolyBase on these tables. If I wanted to monitor the data loading, so there's remember how we had these labels that we put in when we're creating the tables? So you can see from the DMVs what's happening when you're loading via PolyBase. So again, more getting a DBA, have them, him or her, know some of these DMVs. And I have some slides at the end of some common ones that you could use with Synapse that are helpful to see what queries are running, who's doing what we have with loading. Okay, so this is what we're getting. So the trip is the long one that we have. That's the one that's going to have the millions of records in it. But it will tell you as data is being processed how much data is loaded in from a gigabyte level as it's coming in. And because we did column store, the data is compressing, so there's a little bit of overhead as data is being squished as it's being compressed with the index. So you can see where this is at. Let me run it one more time here. Okay, so added, we went up a gig. So Again, we won't be clicking this for 9 minutes. That's pretty boring, but you can monitor the load as it's running to see what's happening. So does that make sense? That key things, stuff in a data lake, they're going to appear as external tables. I could then create into my DBO schema so they're physically in the data warehouse and PolyBase is loading it, and that's one of the fastest methods to get data in. I won't, in practice, you probably are going to have staging tables that you then manipulate, then you would compare to like your fact and dimension or your data vault tables. But I just wanted to show you the basic premise of data lake to actual tables using PolyBase and how much data and how long it takes on the lower settings. Because it could get long discussions on the data architecture and some of those details that might not matter as much. Nothing special. Yeah, it just is using PolyBase. When I get to the Azure Data Factory example, there's a couple packages that we have, and if you do it wrong, it won't use PolyBase. So when Dan and I were doing it, so let's say you have a bunch of files. So the taxi data had 2019, January, February, March, April, May, and so we did a loop. We didn't quite do it right, and there was a little viewer that said using PolyBase with ADF. So we didn't code anything to use PolyBase, but if you end up doing something wrong in ADF, it won't use PolyBase for you. So wildcard specific versus with the for loop. So yeah, we could Google that. Okay, so something that always thought was really interesting. Who here has heard of Fivetran ETL tool? And it might not be common on our list because we're using Azure Data Factory. But something I felt was important is people are saying, I want to use Azure SQL Data Warehouse. I think it costs too much, it doesn't perform. I've heard good things about Redshift, or I've heard good things about Snowflake. How do I know that Azure SQL Data Warehouse makes sense? So I felt like I'll just randomly pick, because we ran across this independent vendor that's trying to move data in back and forth and how they would do some benchmark data. And I know we had seen in our keynote, Microsoft did some benchmarks with the TPC data. But I always thought that this was interesting. Some people, when they're benchmarking, don't optimize the platform. So let's say I came in, I don't know what I'm doing with Redshift, I don't know what I'm doing with Snowflake, I don't know what I'm doing with SQL. I'm going to create tables, I'm going to load data in it, and I'm going to get results back. So without trying to optimize things, what kind of tests would you do? So there were 2 tests that was recommended, working with 100 gigabytes of data, and then when you actually go to 1 terabyte scale. The examples that they worked with were 24 tables that were in star schema. And the data represented web, catalog, store sales that was provided to them. The largest fact table at the 100 gig scale had 400 million rows. At the 1 terabyte scale was 4 billion rows. So running these queries, there was like 99 queries that were run. Some were complex with lots of joins and aggregations. So when we talked about would maybe data vault fit versus star schema, you are going to have joins, you'll have some performance. You can monitor how that looks. But what they did, they ran one once. They would run them through, and there's a interesting thing on how some of the different data warehouses work. So remember when I said you first spin up Azure SQL Data Warehouse, there's some caching and warm-up that's occurring. This is a note on Redshift. Is anybody working with Redshift right now or thinking about that? Okay. So what happens with Redshift, they have a little bit of a warming up issue. So if they haven't seen the query before, you're actually going to have some higher or longer running queries until it had seen it the first time. And so it could be much slower because it's the first time that the query had run. So you could see in their examples, first run versus second run, Redshift had a couple issues on seeing queries for the first time. And you don't see that with Synapse. It's just a different technology. So out of all these data warehouses, this is just interesting, just gut feel. Who thinks Azure SQL or Synapse would be the fastest? Okay. What about Snowflake? No? Redshift? We're not guessing here. Okay, and then we have Presto. Google BigQuery. Are we BigQuery people? Okay. So let's see what happened. So you have to look, let's see, I don't know if I could zoom in more than this. But if we look at the 100 gigabyte scale, so we're looking at Redshift. We're out here in the 19 second per average. So over these queries, they were doing geometric mean. So Redshift, not so great. SQL DW, not so great. Snowflake, 6.12 seconds. So that was actually the fastest on the smaller size queries for the data warehouse. Now there is good news. When this was run, this was on Gen 1, not Gen 2, Azure SQL Data Warehouse. And so they actually made a note. The performance should be better, but they did not rerun it on Gen 2. So Synapse might not be in last place. Let me do one more thing, then I'll get to you. So then on the terabyte scale, so this is interesting. So Redshift was 21 seconds, Snowflake was 10, SQL DW was slightly less than Snowflake, so it was the best on the bigger scale queries. And again, they didn't try to optimize the different platforms. You know, when you're getting benchmarks from a Snowflake or from SQL, they're probably going to do the tricks and do things to make things run better, but they were trying to have a unbiased look at this.
That's only with Fivetran, right? That's not.
Only with, yes. It's just one look. It's not gospel. It's, yeah. Well, and what this is focused on is not the ETL process, but I put data in my warehouse. Now I'm getting it out. So I have a same fact dimensional model, nearly the same in all the different warehouses, running similar queries across all the warehouses. So if you look at the notes, I put the link in here so you could go to the details of case studies, but you're going to see this when you dig into case studies. Didn't optimize, had to slightly change some things because the databases aren't exactly the same. So it's not always an apples to apples comparison, but I just felt that this was a more interesting case study, that it felt one of the least unbiased looks at what you're getting from your data warehousing performance. And what I wanted to take away was, if I were to recommend Synapse, are people going to go, I just don't, I don't believe it's going to perform right. I think it's going to be more expensive. I don't know that I trust it. So again, you need to digest it for yourself, but I thought that these were very interesting results. So the cheapest, what do we think is the cheapest? So if we're looking at, let's go ahead and look at the 1 terabyte scale, again, with the Synapse. It was on Gen 1. Amazon Redshift, on average, seemed to be the highest cost from the study. Snowflake seemed to be just slightly cheaper than Azure SQL DW, but not by much. Presto isn't bad, and BigQuery isn't bad. So you can't argue you could argue, but looking at the graph, there seems to be just very minor cost differences between the platforms. There isn't anything glaring in my mind why I would be afraid to consider Synapse over other solutions. There's not concern there. So finally, the question is, which data warehouse is the best? Well, looking in the case study, it's probably a little bit more about things I could do than just pure cost and performance. Did it seem like it was easy to map to the external tables? Does it seem like it's easy to create tables? Do I understand how the partitioning works? If I run into performance issues, how can I see what's running? A few things like supporting JSON. Synapse can support JSON. There might be some other challenges on the other platforms. So this is your research to do, your homework, is to figure out, do I feel like I like the admin tools? Do I feel like I know what I'm doing? Can I work very easily on mapping my data between these platforms? And that could help you choose to support Synapse, or maybe something's easier in another platform. But those are the considerations. So just Googling stuff, that's my caution. Not quite good enough. I wouldn't just Google things. Okay. So loading data, we saw the PolyBase way. So typical things that you're thinking through on designing your warehouse is loading data as fast as possible using a staging, limiting the data movements. You're going to optimize your tables with the read performance, with the indexing that you're going to have. You could work on the partitioning for the filtering with the dates. And then your goal is to do the incremental loads. So you're really, the data warehouse is online providing value. So that's your architectural design patterns. And again, I'll stop there. I won't go deep into Kimball versus Data Vault, but those are considerations that you have. Repeating again, so design, getting going, loading stuff from data lake, blob storage into there. You're going to use PolyBase on everything. You're going to have a distribution for those tables as round robin. Your indexing would be heap for staging, no partitioning on staging, and then there's a resource that you could get into, which we'll skip. Azure Data Factory. So this isn't really too bad. So when we were working on how hard is it to connect to Synapse in Azure Data Factory, it was pretty easy. It really was fairly intuitive. When we were setting up tables, I think to Dan's point, I labeled something wrong. If I was working on SSIS, it would be 10 minutes to fix, a lot of pain. It was super easy to fix inside of Azure Data Factory. There is, without you having to code things, it'll use PolyBase behind the scenes. It'll use the staging blob feature to work with the high-end loading. So again, it supports the blob storage and data lake storage by default. Resources, running short on time, I won't demo this, but I actually have a Python demo where I could auto-generate an Azure Data Factory with the settings. It just spins it up. Don't need, but I won't do that. So let me do a quick ADF demo. Okay. So a couple things that working with the taxi data, it was in blob storage, but you could connect with HTTP to blob to pull it in. So it will load it into your blob storage. If you look through, let's see, so like the source, so if we're saying I'm connecting to the file, I see the source, it's a delimited file. I have a sink, and then I have some mapping that I have. So out of the file, we're going to see, let me try to zoom in a little bit, like the vendor, the pickup time, the drop-off, all of that from the source. And it does not have to be the same. You could change the names when you're doing the mapping. My thought is I do like moving into a staging table, keeping some things as strings to make my ETL a little easier. Then it can do further manipulation once I land that data. So this is a simple one. Nothing really specific on the settings that we have. We did do, if we're going to Azure SQL, we had that. And so we had this for each loop. So the way that the taxi data was running is that we had one file for January, one for February, one for March, etc. So if you look at the for each loop and we look at the settings, we're going to add the month at the end in this range variable as we run this. And so let me go ahead and click this and then do the debug. Oh, I did forget. Oh, shoot. I forgot one step. Hold on. Well, I forgot to create my table. That's a problem. Okay, so I'm going to create another table that I call this ext trip. And so this is where, so what we loaded before, just so that everybody knows, is 2013 data. And so that was part of what was in the data lake. We're going to actually pull from the taxi site directly into our Azure or Synapse table that we created here. Okay. So I'm actually, it shouldn't be working. Okay. Where is the, all right, let's see here. Yeah, hopefully. Was it? Okay. So under the external table, just so that we're clear, this was the trip that we had before. So let's just make sure we had records. It's running. Okay. Okay, so we're up to 430,000 records that's loading in through ADF that's coming through. So it's running. It's 4.3 million already. All right, let me run this one more time. I'll zoom in for everybody. So now we're up to 7.8 million records. So we're getting some pretty good throughput from ADF into Synapse. So that's exciting. So we won't sit around and wait for all the records. I think again, the benchmark that we had when we ran this was 6 minutes, and we loaded 44 million records in 6 minutes at $1 per hour, and then the Azure Data Factory cost was at the 50 cents an hour cost, so we could throttle that up. So for roughly $2, we're able to load $44 million into our table as a demo. So that's pretty cost effective to show the throughput you could have with Azure SQL DW. Okay. I won't demo this, but this is worth a discussion. So we're talking about streaming analytics. What would we do with that? We know we have capabilities. We could directly stream data into Synapse, or we can land it and load it into a data lake. So did anybody attend the Advancing Analytics pre-con on Tuesday with Databricks? And if not, that's cool, right? But so I leverage this slide, giving them credit for that. You look at where you have some bottlenecks with traditional data warehouse loading. So their point is, I'm going to stage and clean and do stuff in the data warehouse. So if I'm working with external data and I'm streaming data in, I'm probably going to go with loading stuff into the blob storage. So the difference would be using Databricks, which is a common pattern now. I'm going to load it into raw. They're going to clean it into base. Then they're going to transform it into enriched inside the data lake. Then the bottleneck is I'm loading some stuff into the landing. Well, again, on the minimum settings, we loaded 44 million records into our table in 6 minutes. So we could throttle that up and down into the data warehouse. So I thought, just amazing stuff. Good way to leverage Databricks and the data lake to load things through. And then we have 2 minutes left. What I'll do is talk through a few more things. I had some security and then some DMVs. So security, how does this work? When I actually set up the data warehouse and I connect, it will prompt me to say, hey, your IP address isn't allowed to access the SQL server. So as an administrator, I can add IP addresses that are allowed to access it. So even though it's in the cloud, it is restricted by firewall and IP address managed at the server level. Things are encrypted by default. So it's important to understand if somebody went in and tried to change that, it won't let you actually disable the encryption settings with Synapse. It will ignore you trying to do that. So your data will always be encrypted, so you won't be at risk of people hacking it. It does support the transparent data encryption. There is a database encryption key with TDE. And then just another note on security, Microsoft is rotating the certificates every 90 days, and it does use the AES 256 encryption algorithm for it. Last but a couple good things with the DMVs. So if you wanted to see people are querying what's actually happening, this little SQL snippet will actually let you monitor who's querying what inside the data warehouse. And then you could see like the top 10 longest running queries if people are running things, if you're having some trouble inside your data warehouse. This DMV, this SQL, will monitor waiting queries. So you have too much stuff going on, it's going to wait to run some things, so you can see what queries are backlogged and not running. So you guys could dig into that a little bit. There is TempDB as well. So a couple notes that there's to monitor the TempDB, you first have to install a few things from the Microsoft Toolkit for the warehouse to be able to do this. But you could see what kind of issues might be happening if TempDB is running really slowly. It supports that. And then I did run this earlier. So when we were loading, when we were loading the database via PolyBase, you could see the tracking of it, how many bytes are being added with this DMV as well. So sorry I had to rush through the last slide at the very end. I do want to see super quickly if this finished. So not quite done. We're up to 29 million records. Oh, it's, yeah, okay. So, but anyway, thank you. I know I'm a little over time, but I appreciate everybody coming, and I hope that you guys learned a little bit about snaps. Thank you.